SwayamPrabha. Digital India. Educated India.
Welcome once again to our discussion of econometrics, and today we are going to discuss about a specific type of econometric model which is also very interesting and which has very interesting applications also. Many a times we get that type of situation where these models, what we are going to discuss from today onwards, these 3-4 models are going to be extremely useful. First of all, the name of this class of models, they are known as qualitative response model, qualitative response model, okay, or sometimes they are also known as dummy dependent variable model, or sometimes they are known as binary response model. All are same, binary response model. Now, why this is called qualitative response or binary response model? Because the dependent variable, the other name of the dependent variable is response, right. So, let us say that yi equals to alpha plus beta xi plus ui. Now, in the context of dummy variable, what we discussed, sometimes our independent variables, this xi, may become qualitative in nature, and we were discussing about gender, caste, PhD, non-PhD, so on and so forth about this xi independent variable. So, when independent variable is qualitative in nature, we said that we have to convert this qualitative information into a quantitative one using the dummy variable approach. Now, the same dummy variable we can apply in this context also when your dependent variable is qualitative in nature. Okay? That is why the name called dummy dependent variable model, qualitative response model, or binary response model. Why it is called binary response model? Because your response variable yi will take two values, right? We take two values. I will give you some example, right? Let us give some example. Example number 1, let us say that our research question is, why do some individuals own their car while others prefer public transport. So, you are going to explain the factors that can explain the car ownership, right, car ownership. So, when you go to individuals, you will ask, do you own a car? They will say either yes or no, right. So, this is a qualitative information. So, that yes or no information you have to translate into a quantitative format by assigning, let us say, 1 for yes and 0 for no. So, that means y equals to 1 indicates the ith individual is having a car, y equals to 0 indicates the household does not have a car, right. Example number 2, why do some individuals own their house while others prefer to stay at rented apartment. This is another question, right? This is another question that you might be interested. Example number 3, suppose several individuals have applied for loan. Some of the individuals' loan got approved and some individuals' loan got rejected, and we want to know what are the factors that can determine whether an individual's loan will get approved or not, right. So, then basically you will ask the individuals whether your loan got approved, they will say either yes or no, and you have to assign 1 for yes, 0 for no. That means again you are converting that quantitative information, qualitative information into quantitative one using the dummy variable. But in all these cases, the qualitative information is only for the dependent variable, and that you have to regress with what is the collateral that household is having, what is the monthly income that the household is having, what is the dependency ratio, what is the education, sex, gender, so on and so forth. With all these factors, you are going to explain whether the individual's loan will get approved or not, right. So, basically whether here the research question is whether the individual's loan got approved or not. This is the question, all right. So, here that means what I am saying that your yi they can take only two value, yi equals to 1 if having a car, let us say that this is the car ownership problem, if having a car, 0 otherwise. Right. Now, let us also assume that probability yi equals to 1 is denoted as pi and probability yi equals to 0, that is denoted as 1 minus pi, right, 1 minus pi. Okay. Let us say this is equation 1, this is 2, this is 3, right, this is 3. Now, if I take expectation of equation 1, then what I can write, expectation of yi given xi equals to alpha plus beta xi. Let us say that is equation 4, right. Now, I can find the expectation of yi from this formula also, because yi can take two values 1 and 0, and the probability that y will take value 1 is pi and 0 as 1 minus pi, right. So, this is 0 and 1, these are the values that y can take, and the probability is pi and 1 minus pi, 1 minus pi. So, these are the two values y can take. So, expectation of yi from here what I can write, expectation of yi equals to, sorry, this is 1, this is 0, okay, this is 0. So, pi into 1 plus 1 minus pi into 0 equals to pi. Let us say this is equation 5, right, this is equation 5. Now, combining 4 and 5, combining 4 and 5, 4 and 5 if I combine, then what I can write, that pi actually expectation of yi given xi equals to pi, and that again equals to alpha plus beta xi. So, that means this implies pi equals to alpha plus beta xi, right. This is, let us say, equation 6, equation 6. Now, why this model? This model what I have, this is a probabilistic model that we have derived. So, that means when I am saying expectation of yi given xi equals to pi equals to alpha plus beta xi, this model is known as linear probability model, linear probability model. Linear probability model. So, that is the first model in this class of models. That means, linear probability model is the first kind of model of the binary response models. Okay. We have many other models, but this is the starting point, pi equals to alpha plus beta xi. Now, this is called linear probability model. Why this is called linear probability model? That means, this is, in short, I will say LPM. And why this is called LPM? Why LPM? Why this is called LPM? There are two reasons. First of all, unlike other cases, here expectation of yi given xi denotes actually, that means, or conditional probability of, sorry, conditional mean of yi basically indicates probability of owning a car. So, here the conditional mean of yi, expectation of yi given xi, they actually indicates a probability. When we are talking about yi equals to alpha plus beta xi plus ui in the context of consumption function, there expectation of yi given xi or alpha plus beta xi was denoting only the mean income, but here it is a conditional it is a probability. Conditional mean of yi indicates probability of owning a car, and secondly that probability is a linear function of x, that probability is linear in X. Because of these two reasons, this model is called linear probability model. That is all, right? Linear probability model. Now, this linear probability model, it has, though it is the starting point of this qualitative response model, it has some limitations. What are those? What are the limitations of LPM? Can you think of? What are the limitations of LPM? Limitations of LPM. The first one is, as you know from the properties of probability, that Pi should always lie between 0 and 1, right? Pi should always lie between 0 and 1, but that implies expectation of yi given xi should also lie between 0 and 1, and that implies that alpha plus beta xi should lie between 0 and 1. Okay. But as you can see, suppose this xi denotes income, that means we are trying to understand the probability that a particular household will own a car from that household's income, right. Since this is a linear function, as income increases, probability of owning a car will also increase. But as you can think of, let us say income is increasing from 40,000 to 50,000, there would be some increase in the probability. Then again 50,000 to 75,000, another increase in the probability of owning a car. Then 75,000 to 1 lakh, 1 lakh to 1.5 lakhs, 1.5 lakhs to 2 lakhs, 2 lakhs to 2.5 lakhs. So, the probability of owning a car will keep on increasing as x increases, since it is a linear probability. So, it may so happen that at some point of time your probability will go beyond 1, since you are calculating probability with a linear function. So, that is why there is no guarantee that this Pi or expectation of yi given xi will always lie between 0 and 1. Okay. But there is no guarantee that Pi or expectation of yi given alpha plus beta xi, they will lie between 0 and 1. And if that is the case, that means you are actually violating the properties of probability. So, it may so happen that your estimated probability is 1.56, which does not make any sense. So, that is the limitation of linear probability model. Okay, limitation of linear probability model. Right. And then secondly, can we estimate the model Pi equals to alpha plus beta xi using OLS? Can we estimate the model? Right. When I am saying that the expectation of yi given xi equals to alpha plus beta xi, can we estimate the model using OLS? What will happen if we estimate the model using OLS, right? Okay. So, can we estimate LPM using OLS, using OLS. That is also we need to think about. Okay. Now, expectation of yi, that means the model what you are estimating yi equals to alpha plus beta xi plus ui, and y will take only 1 and 0. So, that means depending, so from here we can say that ui equals to yi minus alpha minus beta xi. So, equals to either 1 minus alpha minus beta xi or equals to minus alpha minus beta xi when yi equals to 1, when yi equals to 0, right. So, that means here you see ui can take only 2 value. What would be the distribution of then ui? So, ui, that means this will say that distribution of ui will be discrete instead of normal. Now, if ui follows a discrete distribution, we cannot go for hypothesis testing, as you know, because for that we need the normality assumption of ui. Otherwise, we cannot construct the test statistic for conducting hypothesis testing. So, this is another problem of linear probability model, that first of all there is no guarantee that this will lie between 0 and 1, the probability. Then secondly, we cannot estimate this model using OLS method, because ui takes only 2 values depending on what y takes. When y equals to 1, ui equals to 1 minus alpha minus beta xi and equals to minus alpha minus beta xi when yi equals to 0. So, ui follows a discrete distribution, right. So, this is the problem, right, this is the problem, and to overcome this, econometrician they developed another model which is called Logit model. So, here instead of assuming probability is a linear function of x, what this model assumes that probability pi, which is actually probability yi takes the value 1, pi equals to 1 by 1 plus e to the power minus zi, where zi equals to alpha plus beta xi. Okay, zeta xi. Now, from here what you can do, that this model apparently looks like a nonlinear model. Okay, this looks like a nonlinear model, but you can always linearize this model. How you can do that? If you take 1 minus, if you take pi by 1 minus pi, that would become e to the power zi, and then if you take log of this, then log of pi by 1 minus pi equals to zi equals to alpha plus beta xi, and then you can estimate this model, because now this model becomes a nonlinear model, sorry, a linear model. So, you can add the error term here, and then that is basically the estimable function So, this mathematical model you can convert into statistical one by adding the error term, and this particular specification you can now estimate. So, you can estimate this model. Right, we can estimate this model. But even in this model also, what is your dependent variable? Dependent variable is log of pi by 1 minus pi, and this pi by 1 minus pi, it has a specific name. What is the name? The name is called odds ratio. Odds ratio. Okay.